Hi, welcome to MyProjectBazaar.com. Now let me discuss about the title of the process. The title of the process is time series shapelets, a new primitive for data mining. Now let me discuss about the abstract of our process. A shapelet is a time series subsequence that is identified as being representative of class membership. Classification of the shapelets offers several benefits over competing approaches. So firstly, shapelets are directly interpretable and can offer explanatory insights into the problem domain. Secondly, the shapelet classifier is more compact than many of the alternatives, and hence classifying new instances is faster. Thirdly, shapelets allow for the detection of phase-independent shape-based similarity of subsequences. This type of similarity is often hard to detect with algorithms based on whole series. We introduce a new time series primitive time series shapelet which address these limitations. So while dozens of techniques have been introduced, recent empirical evidence has strongly suggested that the simple nearest neighbor algorithm is very difficult to beat for most time series problems, especially for large scale datasets. While this may be considered good news, given the simplicity of implementing the nearest neighbor algorithm, there are some negative consequences of this. So first, the nearest neighbor algorithm requires storing and searching the entire dataset, resulting in a high time and space complexity that limits applicability, especially on resource limited scores. Second, beyond mere classification accuracy, we often wish to gain some insight into the data and to make the classification results more explainable, which global characteristics of the nearest neighbor cannot provide. In this work, we introduce a new time series primitive time series shapelets which address these limitations. Informally, shapelets are time series subsequences which are in some sense maximal representative of a class. We can use the distance of the shapelet rather than the distance to the nearest neighbor to classify objects. This is abstract of our process. Now let me discuss about the data flow diagram of our process. First we have to start our process. After we have to collect the data set. After we have to pre-process the data set. In our process, our data set is any time series data set. After we have to pre-process the data set, we have to identify the temporal attributes in our data set. So by using the attributes, here we are going to calculate the distance between attributes in the data set. After we calculate the entropy and gain for every attribute in the data set. So by using that, here we find the optimal split values. By using that optimal split points, here we have to classify the data set. By using that information, here we have to predict the classification accuracy. This is the complete data flow diagram of our process. Now let me discuss about the demo of our process. Our process package is time series shapelets. Here we are using two data sets. One is using multivariate data set, another one is using univariate data set. When you click the home.java in using multivariate data set, your home page will be open here. So our title is time series shapelets, a primitive for data mining. So when you click the start button, you have to browse your data set. So go to your package. So path of the data set, we have to find the path of the data set. Time series shapelet. After that, we have to load the data set and we have to convert the data set into the data format, then create table. After that, we have to extract the data into the database. Then we have to load the data and we have to classify the data based upon the attribute, and by using that, here we split that into subtables, and after that we have to calculate the information gain and bound for information gain. After that, we have to calculate Gini value, Gini index value for every attribute. Then after that, we have to bound for Gini index attributes. Then we have to calculate the Gini ratio Then info split values will be calculated here, and then gain ratio, and then calculate the Gini ratio and predict the decision tree, and click the tree for that one, view tree, and based upon that here we calculate the graph. Then after that we have to run by using univariate dataset. So run home.java. So start process, you have to choose your dataset. Then click here format and table creation. You have to click the table creations and click extract. Data extracted. After that we have to load the dataset and classify the data. Then click extract. Based upon the attributes here we identify the subsequences. Then after that we have to identify the time series, and then click next. So based upon that here we are predicting the identities, which is here we have to calculate the distance between the timestamp, and here we have to distance by using clicking distance formula. Then we have to identify the decision total estimation. So by using that we have to cluster the values and calculate the entropy value, information gain and values, and click next button. So by using the gain value here we click the put the optimum time series information, then find direction and classify the data set. So click classify. By using that here we are use time series, here we are classifying the activities. So by using that here we are calculating the timing efficiency and ROC curve. By using that here we evaluate the performance of existing and proposed system by using the parameter called accuracy.